properties you are already familiar with. So we're going to take a look at some of them, and again, a lot of this already still, we're kind of going over stuff that you guys know already. So basic assumptions, again, things we can assume to be true about math, and I'm going to call it properties because that's really what we're focusing on here. So one of the main ones that you have learned about is the commutative property. Oh yeah. This gives us some things we can assume to be true, but only about addition and multiplication. These properties are only true for these two operations, so we don't really have any properties for subtraction or division in the same way. Does anybody remember what exactly the commutative property tells us about math? Commutative. Your parents commute to work, they move a long way to get there. Diego?
You can add and multiply in any order.
Perfect. That you can move the numbers or the variables around. A plus B equals B plus A. Or 2 plus 3 equals 3 plus 2. Right? That we can add in any order. That we can move. Commutative means to move the numbers into a different order. So I'm not going to write down the definition. I think when you see these, they should all kind of come back a little bit. And it's the same for multiplication. A times B is the same as B times A. 4 times 5 is the same as 5 times 4. Right? So that's a basic assumption we can make. And again, you guys are familiar with that already. So we're just sort of reviewing the names of it. We will be using these properties to do some work. Associative property is another one. And again, these are only for addition and multiplication, so I'm not going to keep writing that. But the associative property, who do you associate with? Who's in your group? Do you change groups? What's your hint? Diego. Diego's the only one who remembers 7th grade math. All right, Diego. Okay, good, that the groups can change. Now again, this has to be either all addition or all multiplication. We can't mix it up. So in this first one, I've got B and C grouped together, which according to PEMDAS means we would do that first, right? And poor A is all by himself and has no friends. And then B and C, I don't know, I guess they have a fight. And B goes and hangs out with A, and now C has no friends. C is not in a group. The parentheses are the grouping symbols. Notice, straight up associative property, the order doesn't change. A, B, C, A, B, C. It's just the groups that change. But if it's all addition or all multiplication, that it doesn't matter, even if you're following PEMDAS. And you're doing the parentheses first, that either way, even if the groups change, you will get the same answer. But we can't mix the two. It can't be part addition and part multiplication, either all addition or all multiplication. Now, there are some other properties mentioned in your book, but we're not going to worry about those. They're not anything that you need to know about, or you kind of know the idea behind them, so we don't need to name them. But I want to show you a couple other things now of how we're going to use these. So, let's say first of all that I asked you just to simplify and we're going to do this by using one of the properties. So if I said simplify 7 plus 9m plus 5. If we are adding, you need to look for like terms. Because remember, we can only add and subtract things that are alike. So, if I wanted to combine like terms in order to simplify this, which terms in this example are alike? Vincent?
7 and 5.
Yeah, we can't combine the one with the m with a number that doesn't have an m. So, what property am I going to use if I'm reordering this? I'm going to add the 7 and the 5 together, but that's not the order that it comes in. So if I change the order, what property am I using here? Jaden? No, there's no groups. You gotta look for parentheses. So then the other choice, Kate, commutative. I'm gonna change the order. Now you guys don't have to write this down, but technically what we're gonna do, we're just gonna do it in mental math, is we're gonna change the order and we're gonna put these two together because they're alike, and then I can add them together. This is all you can do. Doesn't say solve, I don't know what M is. I'm just simplifying by combining the like terms. Diego.
Couldn't you just did 7 plus 5 and kept it like that?
Yeah, but when you do that, you're doing mental math, right? What you're doing in your head is you're doing this together, right? You don't have to write this step. You can go from this, do the mental math of putting 7 and 5 together. I'm just trying to point out that in doing that mental math of going, oh, 7 plus 5, I can add those, they're alike, that makes 12, that you are using the commutative property to do that. You don't have to do this step of showing the moving around. You guys are doing it in your head. I'm just kind of showing you, hey, that's what you're doing. You're doing the commutative property. You already use it. Now, another example of simplifying. Let's do one with multiplication. 2x times 3y times 4z. A reminder, you can multiply non-like terms or unlike terms. You can multiply anything you want. They do not have to be alike. It's kind of like with fractions, right? If you add fractions, you got to have a common denominator. If you add with variables and numbers, you got to have alike terms. With multiplying, you can multiply any fractions you want. They don't have to be alike. Same thing here. You can multiply anything. Now, again, just to point out how we're thinking about this with the properties. These are grouped, so we're going to first change the groups, and we're going to change the order. I'm going to use the associative and the commutative properties. Here's what I'm going to do. I'm going to take all the numbers and put them together in a group, because I can simplify by multiplying those three numbers together. Because technically, right, the parentheses are being multiplied, and inside the parentheses, 2 is being multiplied times x, and 3 times y, and 4 times z. If I separate all that into separate pieces, now I'm going to regroup them. And then I can put the variables all together, x times y times z. So I've changed the order, commutative property, and I've changed the groups, associative property. Now, I'm showing this here, so you have it in your notes to see how we did it. You don't have to write this step. I'm hoping that all of you can do 2 times 3 times 4 in your head. X, Y, Z, multiplied, push them together. We can multiply anything. Now, here's the key. If you're doing it like this, the number, if you mush it all together, the number has to come first, and the letters have to go in alphabetical order. That's just the standard way to do it. Don't say x24 zy. Technically, you're still multiplying it all, but that's not how we write it. Number first, ABC order after with the letters. Okay? So remember, for multiplying, you can multiply anything. Now again, you don't have to show this step. I'm showing you how I reorganized it, but you guys could do it in your head. 2 times 3 times 4, 24. X times Y times Z. Oh, push it all together. X, Y, Z. Now, last example I need to show you for this lesson. Last one. What if I just gave you numbers and I said, hey guys, you got to do mental math. You can't write anything down. Uh-oh. And you can't use your calculator. Uh-oh. Shh. We are going to use one of these properties. And I'll tell you right now, we're going to use the commutative property to put these in an order that makes it easier to do mental math with. In the order that we've got here, some of you, I'm sure, could do it. Some of us would lose track of it, trying to do it all in our heads. Does anybody see a pair of numbers that I could reorder and put together to make it easier? Daniel.
11 and 89.
Okay, good. If we reorder it, and now again, you don't have to write the 11 and the 89 down when you do the homework. Whoops, I even wrote it wrong. 11. But if you want to, you can. 11 plus 89 makes how much? CJ? 100. Right? Now, again, on the mental math, guys, if you need to, take the 1 from the 11 89 plus 1 is 90, plus another 10, oh, that's 100. What about the 17 and the 3? Do those go together easily?
Yes.
Yeah, 17 plus 3. Now again, I'm showing you here that we're reordering them, and if you wanted to, you could even make groups to do the commutative and the associative property making groups. But otherwise, you can skip straight to this next line. Oh, 89 plus 11, I can do that and get 100. 17 plus 3, I can get 20. The answer is 120. Reordering the numbers to make them easier to add together in your head is how we can use these to do mental math. And I am going to ask you to try that on some of the problems I give you. Let me give you one more though. How about 6.5 plus 4 1/3, oh no, plus 1.5 plus 2/3. 6.5 plus 4 1/3 plus 1.5 plus 2/3. And I'm not going to let you show any work. You got to do it all in your head. Now, if we tried to do this, working it out, we would find common denominators. But can I group any together that will be easy to add? Good. Jim, which ones do you want to start with?
6.5 and 1.
Yeah, use the ones that have the same denominator, right? Okay, 6 plus 1, if I add the whole numbers, that's 7. A half and a half, that makes a whole, so I have 7 plus 1 more, I get 8. Okay, no more fractions there. And then I could take the ones that have the 1/3, or the third denominator of 3. 1/3 plus 2/3 makes 3/3. 3/3 is 1 whole. So I have 4 plus a whole, that's 5. Hey, I didn't need to find a common denominator. I didn't need to write it down. Mental math. What we're doing is looking for easier ways to do mental math by combining the numbers that go together easily. Now, try the mental math problems doing it this way, please. You're welcome to use your calculator to check your answer, but I want you to try it this way. That's it.